The Food and Agro-Industry Research Center, or FARC, or FARC. Food and agro-industry is a potential field of study because it is related to the economic activities of the country in aspects of agriculture, industry, and the service sector. It is considered a solution to deal with the decline in agricultural product prices, increase the agricultural value, and reduce the loss. Thailand is an agricultural country which can produce high-quality agricultural products to use as the raw material in food and agro-industry businesses. The greater the number of processed agricultural products, the greater the benefits of the country. This is because it can enhance the quality of life of the farmers, stimulate the economic growth, and help improve the overall industrial sector. King Mongkut's University of Technology, North Bangkok, has realized the importance of food and agro-industry and assigned the Science and Technology Research Institute to develop the effective production process in order to increase the value, reduce the loss, and create the innovation. Therefore, the Food and Agro-Industry Research Center was established to be the key mechanism in food and agro-industry research development. The center is responsible for researching new technologies and innovations that can develop and drive Thailand's food and agro-industry to achieve international standards. The objectives and goals of the Food and Agro-Industry Research Center are as follows. First, to promote food and agro-industry research and development, such as utilization of agricultural products, product processing, product development, and increasing value of waste materials. Second, to conduct research studies at the national and international levels. Third, to acquire the patents or other intellectual property. Fourth, to enhance commercial production by collaborating with the industrial sector. And fifth, to provide the private sector with useful guidance related to food and agro-industry research and development.
Okay, so I would like to introduce some works in our research center. The first work is about extrusion. What is extrusion? Extrusion is the process that combines many unit operations such as mixing, kneading, heating, and also forming into one process. Extrusion is very high process, very high efficiency process, and is produced really few effluents and also very high can give many high quality of products. We do a lot of works about productions of noodle. This is rice vermicelli, which like a noodle that made from rice flour. Normally in Thailand or in other countries, we produce rice noodle or rice vermicelli by very long process. It takes about 1 day, starting from soaking and gelatinization, forming, drying, a lot of works. But we can use extrusion to produce rice vermicelli within minutes, very high efficiency. And the texture or properties of the rice noodle is same with the ones that produced by conventional method. We also have rice noodle, like this one that we call select. The conventional method is also very long process, and we can produce this rice noodle by very short process by extrusions. This one is the spaghetti like rice noodle made by extrusion. Just use the rice flour only. We also produce some spaghetti rice noodle by using extrusion, but we use the raw material only rice flour with some modified starch. Normally, the spaghetti that are commercially sold in the market are made from wheat flour, but for our work, we can produce the rice spaghetti from rice flour successfully. Another work, we have produced instant noodle by using extrusion. Normally, the instant noodles that are very popular in Thai people, in Thai market, they are produced by steaming the rice, the noodle from wheat flour and frying it in deep fried oil. Then the content of the oil is very high, normally 18 to 20%. But if you use extrusion, you can get very low fat content because we don't use oil in the extrusion. And the properties of the noodle is quite acceptable. This one, our student just developed an instant lechon that are made from many type of flours and also rice flour and tapioca starch. And the properties or the sensory taste that we have done is quite okay, it's quite highly acceptable. And this work just got they have awarded some they awarded in the innovation contest at our faculty. For the work about extrusion, we have many works that we do the research together with many food industries, and we also got many grants from the private sectors and also from Thailand Research Fund. This work is extrusions of some snack or the product with high expansion ratio. Like this one, we have done research with big snack producing companies, and we have studied the effect of the storage life on the expansion ratio of the snacks, which made from rice flour. No, we can make it from rice flour or from the broken rice. This one we put some more nutritional compositions, ingredients such as the dietary fibers or some byproducts from from many food industry that the ingredients or the byproducts still have high content of good ingredients such as proteins or dietary fibers. Yeah. We are also working about flavor technologies. For example, flavor chemistry, flavor encapsulations, and also the encapsulations of some functional ingredients, such as this work. For this work, we use the syn proteins. What is syn protein? Syn is the byproduct from the productions of cornstarch. Normally, the producers for cornstarch, they will sell syn for animal feed, which is very cheap. So we got the problems from the companies and try to do the value added of the syn protein. So this work we use syn as the capsule to encapsulate some very good components such as this gamma oryzanol. What is a gamma oryzanol? It is the the byproduct from the productions of rice bran oil. This is very good for humans because it has high antioxidant, and we do some work to prepare the nano particles by using this scene to encapsulate gamma oryzanol. And if you see from this result, we can encapsulate gamma oryzanol with syn proteins, and we got very small, about 200 nanometer of the nano particles, and we have applied the use of this nanoparticle to make a cosmetic, because we also have collaborations with some expert lecturers in the field of cosmetic and pharmacies. This work, our student, our master student also got award from this work, and we also got the petty patent for this work too. Okay, we also have some study about the non-food products. For example, the bioplastic and biocomposites compound. Normally, the bioplastic is biodegradable, which is very good for our environments because it's biodegradable and it's green. So we are studying how to value add the natural fibers from agricultural produce or from the food processing companies, such as this one. We have collect the corn husks from corn processing companies, and we just try to study how to produce the fibers and use it as the reinforcement in the biocomposite. This one we use the fibers from the palm oil productions. I mean, this one we call is the oil palm empty fruit bunch fibers, and we study how it is possible to use this fiber for the reinforcements. It's work quite well, and we use the plastic, the PLA, polylactic acid. This one we got the sugarcane bagasses from the sugar processing companies. Normally, the manufacturer for sugar, they will burn the sugarcane bagasses as the energy, but it's very cheap. It's very low value added. So we have tried to produce the nanofiber from sugarcane bagasses and add it with the bioplastic film and see how is the strength or the mechanical properties of this kind of biocomposite or biofilm. We also study for the nanofiber preparations from coconut coir from the company that produce the coconut milk, and it's worked very well. Yeah. This is also the work for the biocomposite that we got a grant, and this work is how to use what we call the hemp. This is the hemp, and normally people will use the hemp fiber to produce some clothes. After that, there will be a lot of byproducts, which is a short fiber of hemp. this one. So we try to add the value to this byproducts by using this hemp fiber as the reinforcement with plastic. In this work, we use the recycled polypropylene, which is very cheap. It's not the biodegradable plastic, but anyway, because it's cheap, we just try to do the reinforcement with that hemp fibers. And for this one is the samples what that we made the biocomposite and then check or measure for the mechanical properties, and it's worked quite well, and we have produced something like this just to show that we can produce this biocomposite and use as something that can be the alternatives for the wood. And we have injected from something like a hangers using this recycled bioplastic. This recycled plastic with the hemp fiber.
Apart from conducting research studies, the Food and Agro-Industry Research Center also provides academic services and technical consultation associated with food and agro-industry to private organizations such as Healthy Home 3PLA Company Limited and Beyond Quality Science Company Limited. In addition, the center cooperates with the Department of Food Technology, Thailand Institute of Scientific and Technological Research to develop processed fruit products in the Cooperative Education Project, and also collaborate with the Community Development Department, Ministry of Interior, to select the best of Thailand's OTOP in the category of processed vegetables, fruits, rice, and grains. The center has received many outstanding awards and recognitions, including 2 petty patents for first, preparation of gamma oryzanol-loaded zine nanoparticles of Ms. Usarapan Pitan Tanakun, which was advised by Associate Professor Dr. Wilai Rangsatong, and second, functional properties of type 1 gelatin from jellyfish of Ms. Ubonwan Rodsawan, which was advised by Assistant Professor Dr. Benjawan Tamtanarak. The Food and Agro-Industry Research Center is committed to work with the mission to serve the society and elevate Thailand's food and agro-industry to the international level.